Okay, today we are still factoring, but now there are some special cases. You could still factor these special cases using our normal rules that we have covered the last few days, but if you notice that they are special cases, it will make it a little bit faster for you to do it this way. So the first one that we're going to be looking at is if it is a perfect square trinomial. So remember, a trinomial means that it's going to have three terms, and perfect square means that the first part and the last part, so A and C, are going to be perfect squares. So if I look here, it says the first and last terms are both perfect squares. So this term, the first and the last terms, no matter what their signs are going to be perfect squares. Remember, perfect squares are like 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, and keep going. Those are all perfect squares. So those are the numbers you're looking for. If that is true, then, and the middle term is twice the product of one factor from the first term and one factor from the last term. Then we'll go over this. So an example would be this. We have 4x squared plus 12x plus 9. Okay, I'm going to go over how we would normally factor it. We would normally say this sign's positive. It means they're both going to be positive. X plus X plus. We'd say the factors of 4 are 1 and 4, 2 and 2. The factors of 9 are 1 and 9, 3 and 3. And so I just have to guess and test and see what will work. Let's say I decide I want to do 2 and 2 here. I know the sum has to add up to 12. Well, I know 3 times 2 is 6. 3 times 2 is 6, which gives me 12. So this is my solution. So if we notice they are perfect squares, so if I look here, I notice 4 right away is a perfect square, and 9 is a perfect square. This would be 2. This would be 3. And it says the middle term, so this middle term of 12 is the product, so multiplication, of one factor of the first one factor from the last one, times 2. So 2 times 3 is 6, times 2 is 12, so it is true. If that is true, you can use the following rule. The rule says that you take A, so the square root of A, so the square root of 4 is 2x, and both our signs are positive. The square root of 9 is 3, and it's going to be squared. So that would be my answer. If you notice here, they're the same thing. It's just much faster if you use that rule. So if we look at the exact rules from our book here, it says if both the signs are positive, that would give you A plus B, which would be the same as the quantity A plus B squared. If the second one, or the first one, is negative, that only changes the sign. So if we look here, this is if A is equal to 1. So 1's a perfect square because 1 times 1 is 1. And then we have 16, so that's a perfect square. That'd be 1. That'd be 4. 1 times 4 is 4. 4 times 2 is 8, so it does give me this middle term. So I can do the following. X, they're both going to be negative squared. So it's x minus 4 squared. And you're done. So it is much faster if you do notice that. So if I look here on my next one, I have 9 and 4. Both of those are perfect squares. So if I check to see if the middle term is correct, this would be 3 times 2 is 6, times 2 is 12. So it does work. So since it works, I know I could do 3d, both of them are positive signs, plus 2 squared. And you're done. So it does make it much, much faster, as long as you remember that rule. If you don't remember it, remember you can always factor it our old way. It just takes a little bit longer. Now this, instead of being both positive signs, this is going to be a negative sign between them, and there's only two terms. So we have a squared minus b squared. If you have two terms, a squared minus b squared, so a and b are both perfect squares, then it will give you the following: a plus b times a minus b. So if I look at this first one, a is 1, b is 64. So that'd be 1 and 8. So that is correct. The difference of two perfect squares gives me the following: am plus 8 and 1m minus 8. Because the signs are going to be different because your c is negative here. So if I double check it just to prove to you that this works, use the FOIL method. Our first ones give me 1m squared, which is the same as m squared. The outside ones gives me negative 8m. The inside ones give me positive 8m, which gives me 0m. And that's why there's no second term right here. And then positive 8 times negative 8 is negative 64. So it does work. That has been proven that it does work. So you can use this if you have the difference of two perfect squares. So example 4. The 4 is a perfect square, and 121 is a perfect square. It's the difference of two perfect squares. So it's going to be a minus b and a plus b. There you go. Okay, example 5 then is factoring out a common factor first. So just like in our last section, if there's anything that you can factor out the GCF first, and then you can go ahead and continue factoring it. So if I look here, 10 and 40, I can factor out a 10. That leaves me with m squared minus 4. Because remember, if you factor it out, you're basically dividing each term by that factor. So now I have the difference of two squares, because I have 1, square root of 4 is 2. Do not forget your GCF out in front, so I have 10 times 1m minus 2 and 1m plus 2. Remember, you do not have to put that coefficient of 1 on there, but you can. And then you are done. Go ahead and complete the quick checks and look at your schedule for the assignment that matches with this section.